Hello students, good morning to all of you. Students, in today's class we will learn about the gravitational potential energy. Before we learn about the gravitational potential energy, we will just discuss about the gravitational field and gravitational field intensity. Then you can easily understood about the concept of gravitational potential. So, according to the Newton's law of gravitation, if two body having mass m1 and m2 are separated by a distance, these are attracted towards the center of earth or surface of earth by a force F is equal to G m1 m2 upon r square. This force or this idea gives us that the two material particles attract each other towards the surface or towards the center of the earth. Okay, so the gravitational field is that field of a mass body in which the another mass body experience the force due to the first mass body at that location. Okay, so the space around a material body in which its gravitational field or its gravitational pull can be experienced is called its gravitational field. Okay, next, gravitational field intensity. Intensity of gravitational field. Okay, gravitational field intensity of a body at a point in the field is defined as the force experienced by a body of unit mass at that location or at that point, provided the presence of a unit mass does not disturb the original gravitational field. original gravitational field. Okay, so as we know that, okay, it is always directed towards the center of gravity, of the body. It is denoted by capital letter I. Okay, now as we know that the gravitational force or the pull of gravity is given by G m1 m2 upon r square, let's say x square inside the earth. And we also know that according to the theory, the intensity is the force experienced by unit mass at that location. Okay, where MO is unit mass. Now, by putting this value of force, we get G m1 mo upon x square upon m naught. So this m naught is cancelled. Okay, so we will get the result is G m1 upon x square. This is the intensity of the gravitational field. Okay, this value is negative in vector form because intensity is a vector quantity. So m1 upon x square, and here is the x cap, where the x cap is the unit vector in the direction towards the center. Okay, here intensity of gravitational field is always negative. Intensity of gravitational field is always negative because of force of attraction. Between two objects. Okay, now if we can say the force is equal to m naught a, and therefore value of acceleration is equal to f upon m naught. So this is also because the force experienced by a unit mass at a location is equal to intensity. So we can say that intensity is equal to the acceleration due to gravity. In place of a, we can also use the value of g. Okay, the acceleration up to which the body is attracted towards the center of the gravity or towards the center. So its SI unit is same as unit of acceleration, that is meter per second square. Okay, and dimension formula for intensity is m0 L T minus 2. Okay. Next, gravitational potential and important point. Gravitational potential. Okay, what is this potential? Okay, so gravitational potential at a point, let's say we have a mass body of capital mass M, whose center of mass or center of gravity, okay, is at O. Now, due to this mass body, its gravitational field is up to r distance till point A, just understood, and this is a location B at x distance, okay, till the force or till the field experienced by the another mass body. If an object which is carried from infinity having a small mass m0, or let's say unit mass, now the work done, okay, the work done to bring this unit mass at a location where the force due to the mass body m experienced by this m0 is called the gravitational potential at that location. Okay, so gravitational potential at a point in a gravitational field of a body is defined as the amount of work done in bringing a body of unit mass from infinity to the point without acceleration. Okay, it is denoted by capital P. Okay, therefore gravitational potential is work done to bringing a unit mass from infinity to that point at where the force experienced by the unit mass in presence of the gravitational force of this first body. Okay, now the unit of this is gravitational potential. Unit is joule per kilogram, and dimensional formula for gravitational potential is m0 L2 T minus 2. Okay, okay, so this is the unit and dimensional formula of gravitational potential energy. Okay, thank you students. Next we have expression for gravitational potential. Let's say we have a mass object whose center of mass at O having mass capital M, and its field experiences at point A, okay, at where a unit mass object O is placed, and at a point from its center of gravity at r distance P, at where we need to calculate the gravitational potential. So if in between A to and P there be a point P which is distances at dx, okay, so we know that the force experienced by the two mass body according to Newton's law of gravitation is Gm m0 upon x square. Okay, this is equation first. Now for bringing a unit mass or a mass of m0 mass from point A to P, okay, therefore the small work done to bringing it from A to B is given by dW is equal to force into displacement. Okay, that is F into dx. Now we have the value for F is Gm m0 upon x square into dx. This is the small work done to bringing the unit mass MO from A to B. Therefore total work done to bringing it from A to P is W is equal to infinite integration from infinity to distance r is dW, that is infinity to r Gm m0 x square dx. Now Gm m0 is constant because G is universal constant, m is mass of the object, and small m0 is bringing from a point A. So Gm m0 is common, and we can write 1 upon x square as x square minus 2 dx. Okay, therefore Gm m0 is x to the power minus 2 plus 1 upon minus 2 plus 1 from infinity to r. Here we can use a formula x to the power n dx is equal to x to the power n plus 1 upon n plus 1. Okay, so this we get minus Gm m0 upon x to the power minus 1 infinity to r, that is minus Gm m0 1 upon x from infinity to r, that we get minus Gm m0 1 upon r minus 1 upon infinity. Okay, therefore work done to bringing a unit object from infinity to location at P is minus g m m naught upon r. Here 1 upon infinity become 0. Okay. Now this work done is the measure of gravitational potential. Gravitational potential at point P. Therefore Vp is equal to W is equal to minus G M 1 minute is equal to m naught. Therefore G m naught upon R is m naught. So this m naught is cancelled and we get the value of gravitational potential is minus G m upon R. This is the value of gravitational potential at a location. Okay, now here Vp is negative always because the force of attraction between the two mass bodies okay students. Now gravitational potential. The potential energy of a body at a position is defined as the energy stored in the body while bringing it from the position of zero potential energy to that position. It is very clear, at zero potential the body has no acceleration. Now by the second view, if the position of a body changes on account of the force acting on it, then change in its potential energy is equal to the amount of work done on the body by the force acting on it for a given change in the position, which means the gravitational potential energy is the energy equal to the amount of work done to bring a mass between the 2 points. Okay, here very important that the gravitational force is a conservative force, which means for the work done by the conservative force is not depends on the path taken by the object from final and initial position. Okay, now for the expression for gravitational potential energy, now consider a gravitational field due to Earth of mass capital M with radius capital R the mass of Earth can be supposed to be concentrated at its center O. Let us calculate the gravitational potential energy. Gravitational potential energy of the body of mass m placed at a point P in Earth's gravitational field. Okay, where OP is equal to R and R is greater than radius of Earth. Okay, therefore now let's say this is Earth having its center of gravity or center O of mass m. From its center a point P at where we need to calculate the gravitational potential energy. Okay, now here a point A which is from its center at x distance, okay, and in between there is a point B. So the small work to bringing the mass m from A to B is dx. Okay, therefore the work done or small work done from A to B to bringing it from A to B is given by f dx, which is equal to gmm upon x square dx. Now total work done to bringing it at P is given by W is equal to from infinity to R g m small m upon x square dx, which is g m is x minus 2 dx. Okay, therefore this W is equal to g m x to the power minus 1 upon minus 1 from infinity to R. Here we are using x to the power minus 2 dx is equal to minus 2 plus 1 upon minus 2 plus 1. Okay, therefore this value become negative minus g m 1 upon x from infinity to R. Therefore this W is equal to minus g m 1 upon R minus 1 upon infinity. Okay, so the value of work done is minus gm m upon r. Okay, this work done is stored in the body at that position. Body at that position. Okay, therefore gravitational potential energy U is equal to minus G m upon R. So we can say here that we have Vp is equal to minus Gm upon R. So we can use here gravitational potential energy is Vp into small m. Okay, that is gravitational potential energy. Okay, so gravitational potential energy is equal to gravitational potential into mass. Here it is very clear that the gravitational potential energy is negative gmm upon r. This is always negative because of the force acting between the two objects is attractive force, and the work done to bringing it from one point to the another point is against the force of gravity. Okay, thank you.